Okay, class, this is 11.4, the basic trig identities. And we did this first part already, but I just want to do a quick review here. Remember, we started off with Pythagorean identities. And the first thing we have to understand is notation, right? Don't forget, if you saw that, you'd know it's sine B times sine B. Well, please understand that that is the same. So again, when you see this notation, you have to understand that it is sine B times sine B. All right? Make sure that you understand that. Okay, then the Pythagorean identity, sine squared x plus cosine squared x equals 1. That's something you got to get into your brain and something you just need to memorize and know. We're going to use that here in just a little bit. I proved it to you using ratios for the sine and the cosine, and I proved it to you using a 35-degree angle for the sine and the cosine. All right? Whether you get that or not is not a big deal. It does work. It is true. Here are the other two forms. We simply took it the first time and solved it for sine squared. So we added a negative cosine squared x to both sides to get that. Second situation, we moved the sine squared. All right, so that's the three forms of the Pythagorean identity. And so be aware of it, and we'll use these. Again, how to use it. Maybe where you see the sine squared x, you'll substitute in 1 minus cosine squared x. Or maybe where you see 1 minus cosine squared x, you'll sub in sine squared x. And vice versa, same thing with the second one. That's how it's used, and that's what we're going to do with it. Okay, next on your sheet come the quotient identities. Quotient identities. The main quotient identity is the tangent of beta, alpha, theta, A, B, C, X, Y, Z, whatever angle, right? Remember, I'm just trying to show you the different possibilities. It's a beta, Greek letter beta, and so tangent of angle beta is the, I'm going to take my red here, the sine of angle beta divided by the cosine of angle beta. All right, that's an important one. Tangent of beta is the sine beta over the cosine of beta. Let me extend my page here and get this up top. All right, so we're going to prove this using opposite, adjacent, hypotenuse for the trig ratios. All right, not a big deal. I'm going to first take my tangent, right? And what is the tangent? The tangent is the opposite over the adjacent. So I put in the ratio for what the tangent is. Equal sign. Numerator. What is the sine, right? I'm looking at the formula. The sine is the opposite over the hypotenuse. I'm going to take my green. Looking back at the formula, that's divided by the cosine. What is the cosine? Adjacent over hypotenuse. Okay, to finish off, I'm going to look right here at this right-hand side of our equation. All right, a fraction divided by a fraction. To do it the quick, simple way, invert the bottom one, right, and multiply. So again, I just inverted the bottom to multiply. Technically, you're multiplying top and bottom by h over a, right? The division rule is a shortcut to that. We've talked about that in the past, right? Anyhow, this is where we're at right now, right? And clearly, you can see how the hypotenuses divide out, and what are you left with? Opposite over adjacent. So see, the tangent does indeed equal the sine b over the cosine b. Now, let's go back up where the formula is, and let's do the cosine, and again, it could be theta, it could be, let's do theta. Another, that should have been black, another popular angle symbol. Cosine, all right, hold on, brother. Slow down, Mr. Scarfi. Okay, so instead of the tangent, let's do its reciprocal function, and let's use the cotangent. And again, I'm going to go theta. Cotangent of theta. Okay, remember, the tangent is the opposite over the adjacent. The cotangent is the adjacent over the opposite, the reciprocal. So look back at the quotient identity. If the tangent sine over cosine, what's the cotangent going to be? And hopefully you said cosine theta over sine theta. And that should make sense. It's the reciprocal. Okay? So those are two key quotient identities. Now, there are identities galore. And if I were teaching geometry, we deal with a lot more identities. If I were teaching advanced math, like next year with Mrs. Winterroad, I would be teaching a lot of identities. In this course, I'm introducing you to the concepts, and so we're not going to get a bunch of them, just a few. So we have a couple key ones. We've got the quotient identities right there, and don't forget the three forms of the Pythagorean identities that I've given you. It is mostly those things and some other things we already know that are going to enable us to answer questions like we have here. All right, let me get my shade up. All right, so this first one, remember we made a correction to it. So we're trying to prove the sine squared A plus tangent A equals tangent A plus 1 minus cosine squared A. Now, a couple thoughts here in trying to prove an identity. There's a lot of different ways you can get there. You take the high road and I'll take the low road and I'll be in Scotland before you. Well, you know, it depends on which way you go as to how long it'll take you, or even if you can get there. Some tracks that you might take might lead you to dead ends. Kind of think of a corn maze. You know, if you've ever been in a corn maze, you start going down one road and it looks good, and then you get to a dead end, you decide, oh, that didn't work, I go a different route. And that'll happen sometimes. There's a lot of different ways you can go. There's a lot of different things you can do. And so, for example, don't write this. If I wanted to, I could change the tangent to 1 over the cotangent if I wanted to. I could do that because indeed the tangent is 1 over the cotangent. All right? I could if I wanted to. So, there's a lot of different ways you can go. Normally with these, you're just going to work off of one of the sides. So I got to choose, am I going to work off the left? Do I want to make the left look like the right? Or do I want to make the right look like the left? I'm going to choose the right-hand side. And I'm going to try to make the right-hand side to end up looking like the sine squared A plus tangent A. Now, believe it or not, this is a very simple problem. And if you didn't see it yet, let me go back one page for you. And do you happen to see this right here? Here, let me focus you there, all right? Let me focus you there. All right, sine squared x equals what? 1 minus cosine squared x, correct? Okay, well, because of that, we can then use that right here. Look at it. Here, I'll keep my magic pen. Look what we got. I got 1 minus cosine squared x, right? I do. So what I'm going to do right now is I'm going to make a substitution. And where 1 minus cosine squared x is, I'm going to place sine squared x in its place. On the right-hand side, I still have the tangent of A, and I still have the plus sign. And look, lo and behold, if I were really want to be technical, I would do one more maneuver, and I would use, whoops, that should be an A. I would use the commutative property to switch the order, and I end up with sine squared A plus tangent A equals sine squared A plus tangent A. And we proved it. That's the idea. That's the idea. Now, by the way, I could have also worked off the left-hand side and changed that to 1 minus cosine squared A and had the left look like the right, right? Again, there are different ways to approach these and different tracks you can take to get there. So it's not always a right way and a wrong way. All right, let me pull the shade for a little bit because I might need that portion of it. Okay, here we are with our second example. Example B, cotangent theta over cosecant theta equals cosine theta. And again, I have to make a decision of which side am I going to work off of. Generally, the more complex side is the way to go, and that's a generality, but it is a tip. And obviously the left is more complicated than the right, so I'm going to work off the left. You know, I'm looking at this, and the first maneuver I'm going to do is I'm going to take this cotangent. Didn't we just learn that the cotangent is the cosine over the sine, right? So that's the first maneuver I'm going to do. I also want to work on the cosecant. What can I replace the cosecant with? Well, if you remember your reciprocal ratios, it's 1 over the sine. So that's where I'm at right now, right? So now I have cosine over sine divided by 1 over sine. Now again, remember shortcut. If I flip this up and multiply, look where I end up. The sines divide out, and indeed the left side is cosine theta equaling the right side of cosine theta. And that's it. If you went that route. You can go other routes. You can do mathematical operations if you want. But again, the way my mind works, I saw that route and I went that route. But you got to end up with the left side equaling the right side. So let's do another one. So again, if you want practice, you should pause the video and try it yourself. If you want, you can start the video and maybe I'll give you one piece of information. You can pause it and keep going from there. All right. Now, before you pause, let me tell you this, though. Again, we got a left side and a right side, and you got to decide which side to go for. A big hint is usually the side with the addition on it is what you want to work on, because how in the world do you get two things to become one? And that's what you got to work on. So I am going to work on the left side and try to get it to equal that right side. So that's how I'm going to start. Okay? First thing I'm going to do, again, I'm going to take my cotangent and change it to a cosine z over sine z. See how we're using that reciprocal, that quotient identity? All right. Again, pause it if you want to try to go on from here. Plus, and you know what? I'm going to do the tangent as well. What is the tangent? Sine z over cosine z. Now look, don't let the trig functions get you all crazy. This is nothing more than fractions. And how do I get two things to be one? I have to add the fractions. How do I add fractions? Oh, hopefully your brain says, I need a common denominator. Okay, how are you going to get a common denominator? Well, I'm going to multiply the left side by cosine z over cosine z, right? The left fraction. And I'm going to multiply the right fraction by sine z over sine z to give them a common denominator. All right, just for clarity's sake, let me show you where I'm at. Cosine squared z plus, right, that's right here, plus I'm adding the numerators, sine squared z all over the common denominator, and I'll leave it cosine z sine z. Agreed? Okay, where do I go from here? Where in the world do I go from here? I wish I had some direction. And I wish I knew somehow what to do to get some direction from here. I just wish I had a clue. I just wish I had some kind of clue on where to go from here. Right? We've got an asterisk next to that identity, don't we? We do. Because hopefully you see the sine squared x plus cosine squared x. What does it equal? It equals 1, right? Sine squared x plus cosine squared x equals 1. Oops, I don't know how I get back to that. All right, that's good. Let me scroll down. So, look right here. Here is sine squared x plus cosine squared x. Now, you can take the time and use the commutative and flip it, but we don't need to do that. We know that they equal 1. Now, it's at this point, it would be your advantage to peek where you're going. Hey, if I told you to drive to Oshkosh, would you know how to get there? Yeah, I put it in my GPS. Yeah, I know. Before you had GPSs, you had to know where you were going. That's where you're going, right? That's where I'm heading. I have to know where I'm going. Let me get rid of this shade. So that's where I'm heading, right? So where am I at? Well, hey, how about if I split the fraction up? isn't 1 over cosine z times 1 over sine z, isn't that what this is anyhow? Right? I unmultiply them and really factor them, right? Because if you multiply them, don't you get 1 over cosine z sine z? Hopefully you agree, right? Don't you? All right, watch, we're almost done. What's 1 over the cosine? It's the secant. Yeah. And what's 1 over the sine? It's the cosecant. Look it. We just got the left side to look like the right side. All right, and that was a pretty good one because there were a lot of operations. That was a good example one to give you an idea of all the ins and outs and what's involved and what you've got to do to come up with the correct answer. Okay? Now let's look at this last one. All right, one more example here. I've got just about enough time left in my day. All right, I'm kind of scrunched there on the right-hand side. Sorry about that. Again, I got to choose left side or right side. There's my clue. I have 2 things on the right and 1 on the left. I'm going to work on the right-hand side. So I'm going to work the right. Again, if you want to do it yourself, pause the video. Work on the right-hand side, see if you can get it to be the left-hand side. Okay. So I'm already looking, and I'm saying, you know what? I got to add these fractions up. How do you add fractions up? I need a common denominator. All right, let me squeeze this in. So I have to multiply the top by sine A and the bottom by sine A, right? Now I'm ready to add my numerators. 1 minus sine squared A over the common denominator of sine A. You okay with that? 1 over sine squared A. So again, watch. 1 minus sine A times sine squared A, right? That's how the top got there. And then what's the bottom? The common denominator of sine squared A, or sine A, I'm sorry. Right? Okay. Wait a minute. I wish I had some direction and where to go from here. I wish somebody would have told me something that would have helped me from here. I wish there would just be something that would give me some direction. I just don't know what to do, and I'm just confused. And these things are so hard. And how do I think up all this stuff in my head? And where in the world am I going to get any help from? And I just wish I had some help. All right, how come that's not working? Magic pen, you're not being magic here. Come on, magic pen. There we go. All right? Don't we have that? Didn't I give that to you, the other forms? Because you know why you're going to use them. Look, what is 1 minus the sine squared x? It's a cosine squared x. Let's go make that substitution. Look right here. Here it is. Let's put in its place cosine squared A, right? Cool. Okay. Let's look again at the left-hand side. Where am I heading? Where am I heading? Where are you heading? 2 things. What do I have? 1 thing. Split it up. Split it up, you'll have 2. Cosine A over the denominator times cosine A over 1, right? Again, if I went back again, what's this times this? Cosine squared A. What's this times this? Sine A. See what I just did? I split it up. I split it up. And why did I choose to split it up the way I did? Look at this. What's the cosine over the sine? That's the cotangent. And we already have the cosine. We did it. We just proved it. All right. Look, these are tricky. I won't minimize that. And some of them you'll have to take a little time with. Now, some will go quickly, and look. I gave you 1, 2, 3, 4 odds, and you know those answers are in the back of the book. Now, you'll be a fool to just go right to the back of the book and copy what's there. You can do it, but you'd be a fool. So you need to figure it out. But go ahead and do it and see if you get to the right place. You get stuck, use the book to help you. use the book to help you. But just don't go right to the book. You'd be a fool. You won't be helping yourself. And then you only have a few evens there to really show if you got to know what's going on. All right, some will be easy, some a little bit more trickier. But that's the lesson due on Monday. All right, have a great weekend.